Hello dear students, welcome back to another lesson. This is Mr. Muhammed Azeez. We are going to continue on grade 12 book. Previously we solved questions 1 until 8 in chapter 4 section 1. Today we are going to solve a couple more questions in this regard about increasing, decreasing critical values. Then we'll continue in chapter 4. We begin with this question 10. It's trigonometric, probably not students' favorite question, but it is indeed very important. Let's do it. Firstly, this is the question. We need to find intervals of increasing and decreasing. Let's find critical point as well. And critical point that consists of x and y. Let's start. In order to find increasing and decreasing, we start with derivative. F prime x equal to derivative of x is 1 minus derivative of cosine is negative sign. With this negative will be positive and the 2 stays safe and sound. Sine x. 1 plus 2 sine x, that is the first derivative. In order to find critical values, I'm going to set this to be equal to 0. 1 plus 2 sine x equal to 0. Now to solve this, I try to keep sine all alone on one side. I'm going to send this 2 and 1 to the other side. Then 2 sine x is equal to negative 1. Divide by 2. Sine x equal to negative 1 over 2. Negative 1 over 2 is sine x. What's missing is x, that's the angle. I need to use sine inverse. Use calculator. Shift sine negative 0.5. Shift sine negative 0.5. And don't make any drama at this point. Don't say this calculator is not allowed for me. Your calculator can do this, definitely. Shift sine negative 0.5 is equal to negative 30. This negative 30 is the value of x. X equal to negative 30. This negative 30 is going to be the key to find all the possible answers. But if you look at here, the given interval is from 0 until 2 pi is 360. From 0 until 360. While negative 30 is not in this interval. Then what we do, we're going to add this number to 180 and subtract it from 180 to see which one gives a good result. And then we will add and subtract to 360. Okay. Negative 30, which is the answer I got, plus 180 becomes negative 30 plus 180 is equal to 150. 150. I need to test this 150. This 150, if it's the correct answer, when I write it here, I should get the result negative 1 over 2. If not, I don't accept 150. Again, using calculator, sine 150. Result 1 over 2. Then this 150 is not acceptable. This answer is rejected. You don't spend time on it. It's just reject. Another attempt to find the other possible answer is 180 minus negative 30. This will be plus 180 plus 30. Don't be too creative in the exam. Just use calculator and play it safe. 210. I know you are too smart, but the exam anxiety can ruin that. 180 minus negative 30 is 210. Checking again. Sine 210 is equal to negative 1 over 2, negative 0.5. That is what I need. So x equal to 210 is a possible answer. It is between 0 and 360. and it gives the result of -1/2. So I got the first possible answer, which is very good. Now, on this answer, I'm going to add and subtract from 180 again to get another possible answer. You know, when I explain, it takes some time, but when you do it yourself using calculator, it does not take more than 30 seconds. Because you don't need to write, you just test out, find the numbers, then check if the number gives the result of -1/2 or no, then you're good to go. 180 plus 210, 180 plus 210 gives the result 390. 390 is not here, and if we subtract, we will get +30 is not also a possible answer. Then this 210 itself is the answer. It does not lead to any other possible answer. Then we just go back to the -30. This time we add it to 360. 360 plus -30 is, this will be less than 360. This is why I accept this addition, because it's originally subtraction. 330. Sine 330 is -0.5. That's cool. I got the other possible x, which is 330. Now, in the exam, you might see the multiple choices in terms of pi, as the question itself is given in terms of pi. Then again, it's very easy. Divide this number by 180, add a pi next to the result. Okay. Again, using calculator, very good gadget. 210 divide 180 is 7/6. Your calculator can do this as well. You have a button here written ABC. If you press ABC, it makes decimal, fraction, or if it didn't, press shift, then ABC, you will see the fraction. Now, as fraction, this x value is 7/6 pi. Okay, and this one, if I divide by 180 and write pi next to it, 330 divide 180 is equal to 11/6 pi. So result 11/6 pi. Now I have two critical values. Both are in the domain of 0 to 360, and they both satisfy this equation. Okay, now we got the critical values, and this is sine function. Sine will not be undefined. It's not rational, it's not radical. Then I don't try to find where f prime is undefined, because it is not. That's x, f prime, f. The x's I have, this is for me, this table is for me, it's not part of the answer that someone is going to check for you. I'm going to use the 210 and 330 themselves. 210, 330. More than 330 is 2 pi, which is 360. For testing, I'm going to use 335. That's a test number. Between 210 and 330, I'm going to use 300 for testing. And less than 210 in the interval, we have 0. And between them, I'm going to choose 200. Alright. Now, substitute these into the derivative here, and let's see if these numbers make the derivative positive or negative. Again, calculator. 1 plus 2 sine 200. Result is positive. I don't care about 0.3. I care about the sign. That is positive. Same thing for 300. This is negative. And for 335, result is positive. So this side is increasing from 0 to 210 is increasing. From 210 to 330 is decreasing. From 330 to 2 pi is increasing. If I write it as interval, this is where I need the x's in terms of pi. I can say from 0 until 210 in terms of pi, or in radian, is 7/6 pi. From 0 to 7/6 pi is increasing. Union with, there is another piece of increasing, which is from 330, that is 11/6 pi, all the way to 2 pi. These two pieces together are increasing. Decreasing is between these two, 7/6 pi, all the way to 11/6 pi. This is the interval of decreasing. Now let's go back to the book. Question 17 is a good question. Let's directly go to question 17. These are all ordinary questions that everyone can do with some basic understanding of the concept. Now let's go to question 17. Very close. There you go, question 17. In question 17, we have a fraction x power 5 minus 5x all over 5. Okay. The worst thing that someone can do is to say 5 cancels 5. This is the worst mistake that someone can do. You can do mistakes, there are good mistakes, but this mistake, if you cancel these two 5's together, is the worst one. Alright, to find intervals of increasing, decreasing, we start with finding derivative. The derivative is 5x power 4 minus 5 over 5. 5 is common factor, up, we can write it as 5. X power 4 minus 1, divide everything by 5, over 5. This time 5 cancels 5, because this one is not next to any plus or minus, and so this one is not next to any plus or minus. Here, because of this minus, we could not do this cancelling. Alright, now we have the derivative. To find critical value, we set derivative equal to 0, x power 4 minus 1 equal to 0, 1 to the other side, x power 4 is equal to 1. 4 is an even number, so x will have two possible answers, positive, negative 1. So both of positive and negative 1 are critical values. Then more than positive 1 for testing, let's choose 2 and put 2 here into the derivative. 2 power 4 minus 1 will be positive. Between negative 1 and 1, 0 is a good number for testing. If we put 0 here, 0 minus 1 will be negative. And less than negative 1, let's say negative 2. Negative 2 power 4 minus 1 will be positive as well. Now all the intervals are clear. Everything is set. Now question 19 and 18 as well. 18 is a very good question as well. Let's do them. 18, 19, take them to the operational room and we'll operate them. Okay, these are the nice questions. Question 18, x power 2 over 3. You really need to recognize this power 2 over 3. This has a sharp corner. The graph of x power 2 over 3 is 2 wings. 2 wings. In math, this is like Bala Khoshaka, that's an iconic function. Bala Khoshaka is x power 2 over 3. This has a sharp corner. Where the sharp corner happens, the function is not differentiable. This is a very, very common question since 2020. Okay. This sharp corner happens right here. What makes this 0? Since x is alone, x equal to 0 makes x power 2 over 3 to be equal to 0. If we have a bracket, x plus 1 power 2 over 3. What makes inside the bracket 0? Negative 1. Then the sharp or the cusp happens at negative 1 for this function. The cusp or the sharp corner happens at 0 for the question of exercise 18. Okay, now that is clear. We know this function is not differentiable at x equal to 0. And another very common question is for the same function but about continuity. This function at x equal to 0 is continuous. This function at x equal to 0 is not differentiable. This cannot be clearer than that. Okay, to find intervals of increasing and decreasing, we know how to do it. Step 1 is derivative. Power goes down. X power minus 1, 2 over 3 minus 1 is negative 1 over 3. 2 over 3 minus 1 is negative 1 over 3. We don't have time for silly mistakes, so use calculator. Derivative of negative 4 is 0. This is the derivative. Remember, if power of something is negative, this negative power cannot change the sign of the result. The result depends on the x. Alright, now what makes this derivative to be equal to 0? 2 over 3x power negative 1 over 3 equal to 0. Is this possible? Well, that is a trap. If you say x equal to 0, sounds a little bit correct, but it's not. X has a negative power, so it should go down. The function looks like this: 2 over 3, the 3 is already down, and x power positive 1 over 3 goes down, equal to 0. In chapter 1, we said if we have number over something, this function is never equal to 0. Alright, that means we don't have critical value in this way of f prime equal to 0. But there is the other way where f prime equal to undefined. F prime x is equal to undefined, or it will be undefined at x equal to 0. So x equal to 0 makes f prime undefined. If we check here in f of 0 is equal to negative 4. It's not undefined. Since f prime 0 is undefined, f of 0 is negative 4, not undefined. That means x equal to 0 is critical value. X equal to 0 is critical value. Why? Why, mister? I don't understand. Listen to this carefully. X equal to 0 makes the derivative undefined, but makes the function okay, negative 4. That's okay, that's not undefined. So whenever you see this, undefined, defined, the value x equal to 0 is critical value. Then this is the only critical value, because this function will be undefined only at x equal to 0. And if we want to solve, it cannot be equal to 0, the derivative. Then we make a table. We have only one critical value, 0. More than 0 is infinity for testing 1. Less than 0, negative infinity for testing negative 1. This is x, f prime, f. Okay, if I put negative 1 into the derivative, doesn't matter this one or this one, they're both okay. Then use calculator, bracket, negative 1, close bracket, power. In your calculator, you have negative 1 over 3. You can write it like this, 1 over 3. Close bracket, press equal. The answer is negative 1. Okay, if negative 1 is multiplied by 2 over 3, result will be negative. That is decreasing. If you remember, I said the shape is like this. So on the negative side, it is decreasing. On the positive side, if we put 1 in place of x, positive 1 power anything will be positive 1. Then times this fraction stays positive. This side is increasing. Now, interval of increasing is from negative, that's decreasing from negative infinity until 0 is decreasing. From 0 until infinity is increasing. I have a note for these two questions. Study their graphs. In the exam, you are not 100% yourself because the exam is in June. It's pretty hot, and you will be in a school that you have never been into, maybe. And the teachers there, the manager of the exam hall, they don't really care about what is going to happen to you mentally. I know they do their best for you to do the exam in the safest possible environment, but it is new for you. Then you might not remember all of these details, especially about these two functions, absolute and x bar 2 over 3. Then I always recommend to study these two types of functions graphically. Now, if I look at this function, I know there is a sharp corner and there is -4. The sharp corner went down 4 units. If I graph properly, I can immediately find intervals of increasing, interval of decreasing. I can find critical value. I can decide if the critical value is maximum or minimum. The graph is like this, and this sharp corner is at 0, -4, because when I put 0 in place of x, this part that has the power will be 0, and if I find f of 0, result is -4. So as point 0, -4 is this point, it is called turning point sometimes, or it's the critical value, critical point, whatever. The point is here at -4, and the graph goes like this. There is a sharp corner, so if the multiple choice asked for f prime 0, you are going to say it is undefined because there is a sharp corner at x equal to 0. 1. Number 2, interval of decreasing, that's clear, from -infinity until 0. Remember to write intervals. Whenever you write intervals of increasing and decreasing, never mention any y value. That is a very common mistake. Students here, they say this graph is at -infinity until -4. No, this graph, this interval of decreasing is from -infinity until 0. X is interval. Say that again. X is interval, not y. For increasing, decreasing, concave, convex, always it is about x. So, and basically they are going to write this -4 in some of the multiple choices. That looks correct, but it's not. And feels good to choose something containing -4. As you see, -4 is the head of the graph. Alright, from -infinity until 0, that is the interval of decreasing. From 0 until +infinity, that is the interval of increasing. Is the function continuous at x equal to 0? Yes, because f of 0 is equal to -4. At 0, there is an answer. That means it is continuous. Limit x tends to 0 on the right is -4. Limit x tends to 0 on the left is also -4. Then the function is continuous at 0, but not differentiable because the derivative is undefined. Same thing for absolute value. It has a V shape, and there's a negative right in front of the absolute value. The V shape is upside down. We can find this point by finding the x value that makes inside the absolute 0. What makes inside this absolute 0? X equal to 5. That means this is 5 on x-axis, and if we put 5 here into the function, f of 5 is equal to 5 minus absolute 5 minus 5. Result is absolute will be 0, that is only 5. So this point as point is 5, 5. So the graph is like this. Now, if I want to find interval of increasing, that is easy, from -infinity until 5. Interval of decreasing is from 5 until +infinity. At which value f prime is undefined? F prime will be undefined at the sharp corner, and the sharp corner happens at x equal to 5. So if I write f prime 5 is equal to undefined. If we turn this to a question, is f continuous at x equal to 5? The answer is yes, because when I put 5 into f in place of x, I will get a result. I will not get undefined. So f is continuous and all the intervals are clear. Then again, I'm saying it, for questions like this, x power 2 over 3, x power 4 over 5, all of these have sharp corners, then study them graphically. Absolute and x power even over odd, and the power is less than 1. Let's go back to the book, solve some more questions. This is absolute value. That's another way of solving question 19, but again the graphical way is the best. These questions are pretty straightforward. Just find first derivative equal to 0 and be happy. There's another question, question 24, which is very important, and today I don't have time for that. Next lesson we begin with question 24. Stay tuned. This is the end of this lesson. Thank you so much for watching. Don't hesitate to comment your questions. See you in the next lesson.